Okay, I'm going to show you how to solve this problem from the book. This is one example of a buoyant force problem. Now, they're all not going to be exactly the same. These ones are kind of tricky. You have to just look at the equation and figure out which one to use. If you remember, we had a couple equations we use. We would look at, and if we were going to list them, we would just list force net. Net equals mass of the fluid times gravity minus mass of the object times gravity, and then that would give us the force net acting on it. That's one of the equations. And then the other one we can just kind of change this one, and instead of having mass, we can do the density of the fluid, the volume of the fluid, how much was it displaced, minus the density of the object times the volume of the object, and then we do all that and we multiply by g, and we can solve that way. And then we're going to look, I'll list these and then we'll look at which one we think is the best equation to use. The other one we have is the force of gravity over the buoyant force equals the density of the object times the density of the fluid that it's submerged in. So then we look at the problem to see what we have. It says a bargain hunter purchases a gold crown in a flea market. When she gets home, she hangs the crown from a spring scale and finds the weight of the crown to be this. So this is its weight, like putting it on a scale. The reason she uses the spring scale is because then she's going to say she then submerges the crown in water. So on the spring scale, she puts it in water to find out that the scale now reads 6.86 newtons. So it's lost weight by putting it in the water, and that's due to the buoyant force. Okay, so this is going to be caused by F of B. Okay, and it wants to know, is the crown made of pure gold? So we're going to want to know, does this object have the density of gold? P of O. So we have these two things. So we look at these equations. So the force net, we really want to, the thing we want to focus on is density and buoyant force. So we look at this equation, we don't have that. Here we do have some density, P of F, and we have some volume. But we look at our problem, we don't see any volume. So probably not this one. Probably not this one. We'll check this last one. So force of gravity, we have that. She hangs it on a spring scale. She gets the force that gravity's acting upon it. The buoyant force, it doesn't really tell us. It tells us the apparent weight, which is this. But we can figure out the buoyant force. I'll show you in a minute. And then the density of the object, that's actually what we want to figure out. Okay, to say whether it's gold or not. And then the density of the fluid, we know it is water, pure water. And we can know, if we looked in the book, 1.00 times 10 to the third. Okay, so we kind of know that's kilograms, I think times liter, might be meter, I don't know. I'd have to look, but if you look on in your book on page 275, it is kilograms times meters cubed, or liters is the same thing. Okay, so that's our water. So we could use this one because we know this. We know this. We could figure this out. We could check this to see what it is, and then we know the density of the water, so we would just solve for this. The first thing we have to do, though, is solve for the buoyant force. So I'm going to erase these things we don't need carefully. And then I'm going to try to move this up here. Okay. And then we're going to start putting in what we know. So we know the force of gravity is this, 7.84. And then we're going to divide that by the buoyant force. Well, you might think this is the buoyant force, but it's not. There's a force that's opposing this 7.84 to give you this. So if you just took 7.84 and you minused 6.86 from it, that would tell you what the buoyant force is. So we'll do that. So 7.84, that's its weight in the air. We minus it by the weight in the water, 6.86, and we'll get 0.98. That's the buoyant force. That's this force is opposing this force in the air, and it gives you this new apparent weight. So if we just put that right here, 0.98. Okay, and then we want to, the other side, we just need the next two. So we don't know the density. We're going to check the density and see if it matches gold. So P of O, that's going to tell us whether the crown's gold or not. And then the density of the water, which is 1.00 times 10 to the third. And then we just rearrange this, which would end up being P of O. The density of the object is equal to 7.84, and then we could times it. We should know that 1.00 times 10 to the third would just be 1, 2 would be 1,000, right? So we could just write it out like that. And then we would divide that whole thing by, because this would go over here, divide it by 0.98. Right, and then we just take this, it's going to be 1, 2, 3, 0, so we go 1, 2, 3, it'd be 78.40 divided by 0.98. And our answer would be, if we did our calculator, be 78.40 divided by 0.98, and we get 8,000. So we get 8.0 times 10 to the third kilograms per meter cubed. Right? Now we know what the density of this is. Now we check it with gold. If we look in our book, page 275, we see as gold is 19.3 times 10 to the third. So AU is 19.3 times 10 to the third. Better change color. And that's more. So this is not gold, it's something less dense. So the answer would be no, it's not a pure gold crown. So let me know if you want me to go over this in class again, I'll be glad to, and hopefully that helps you solve some of these problems.